looking at the soil food web. And what I want to do is go through a couple of examples, the kinds of things we have to do to overcome the problems, and how did we specifically do that in these specific examples. So the first one I want to talk about is work that we did with Camperdown Compost Company. And Tony and Nick wanted to make compost for all the surrounding dairy farms. And this is down near Melbourne in Australia that we first started working. When they first started out, they wanted to take all of the waste materials from the dairy farms and compost them. And because the farmers were bringing in all of that material in big trucks, the paunch, the manures, all of that, they figured that these farmers would then want to turn around and buy the compost once it was finished. But the shipping costs the transportation was more than the farmers could bear. And so they didn't come back to buy the compost. And Nick and Tony kind of went, what are we going to do? We had 3 farms that they were basically going bankrupt. And so they figured, why not try something different, try something new? And so when we suggested to them that we would bring the equipment to their farm, and we would arrive and be able to turn their compost piles, what the farmer had to do was build the compost piles and let us know when they were finished building. So the woody material would go down, so whatever bales of spoiled hay going in, wood chip material that they were all getting from their own farms, the green plant material, harvest along the weeds along the road, anything that was cut when it was green could go in as green materials. Food waste from the farm would go in, and then the high nitrogen would be the manures that they got from the milking parlor. And so just pictures of the farms when we first started out. Whiting's farm, Jeff Davis, and then so those are the 3 farms that we were working with. The issues that were really plaguing these farmers were that the fertilizer costs were going out of control. They were going bankrupt because they couldn't afford those inorganic fertilizers that they were being told that they had to add to the soil. They had all kinds of insect problems on their lucerne, their high nitrogen crops, so they were feeding their animals some of that lucerne, so they had to buy insecticides, so huge costs there. Each year the animals would be taking a mouthful of the grass, and they would rip the grass out of the paddock by the roots. So huge bare spots starting to happen in their farms. And if you notice on a couple of those pictures I showed you right off, you could see some massive bare areas starting to happen in their paddocks, which means they've got to pay $20,000 in order to reseed their paddocks. Huge costs happening. You can see where they were going bankrupt. They didn't have any clover, so in the pastures themselves, they weren't getting any nitrogen fixation. Profit margins weren't good. They were having to get the veterinarians out to the farm 2 or 3 times a month. And so just the veterinary bills were really hurting the bottom line. And they had no waste management plans. So when the animals come in to be milked, they would feed the animals a little bit of food while waiting to go into the milking parlor. And so, of course, they had all of the manures on that surface. They would wash those off. There's the manures going into the highly odorous pits that here in the United States back in the 1940s, the USDA had said the way to deal with your manure is to dig pits 15 feet deep, 100 feet long, 50 feet wide, and by the time your manure fills up those pits, we'll have figured out what to do with it. Only they didn't. And so when we were working with most of these dairy farms, they had 2 to 3 manure pits full of manure. Imagine the smell. Imagine the disease load. All of the flies laying eggs and the larvae and the next, it was just disgusting. It was hard for me to be out here on these dairies because every time that fly landed on my face, what had they been walking in before they landed on my face? Gross. So how are you going to deal with this? This manure, we convinced them to dig out their manure pits and then put that manure into their windrows. There we are. The farmer builds those windrows and then lets us know when to come out with the turner. So we come out, we turn those windrows and start the composting process. So there's the little turner, one of the mighty mics, and turning. You can see that there's a lot of wood chips. They've got some waste seed material. So whatever you've got kind of goes in. We just have to make certain that it's in right percentages. About 50 to 60% woody materials, so straw, wood chips, stocky materials, and then about 30% green, and about 10% high nitrogen. So the farmer then has to measure temperatures so we know when to come back with the turner. And so we're starting to make compost on farm for all of these farmers. So applying 3 tons of that really good compost, we check the biology to make sure that they're getting the proper organisms, it's staying aerobic during that whole composting time, making certain that it's getting up above 131 degrees Fahrenheit for a full 15 days, during which time we turn the pile 5 times, meeting organic regs. So applied about 3 tons per the hectare, so that's 1.5 tons to the acre. In the first year, we said you could add calcium nitrate if you felt like your soils weren't properly flocculating, you weren't getting good infiltration into the soil, which is a problem that they had before we started working with them. If they saw fertility issues, we said they could go ahead and put on fish or use tea sprays. They didn't have to use any of those practices. So 1.5 tons to the acre, and look at the clover starting to come up right away. So huge improvement in the fertility in that soil. They had a lot of fun looking at how rapidly the grass started to regrow. This particular pasture had been grazed 10 days earlier. And look at how fast that grass is starting to come back. You could bring your animals back out to this field today, 10 days after we grazed it and brought that grass down to about 50% of the original material in that pasture. 10 days later, we could bring those animals back because the grass has grown that much. They wanted to dig down into the soil here and find out how deep the root systems of the grass and the clover had actually started to go down. When we originally started with them, there was a compaction layer at about 2.5 inches below the surface of the soil. In the bare areas, we had a compaction layer right at the surface. That's because when you have evaporation off the surface of that material, of your soil, you're going to bring all the salts, and now you have a salt layer left behind as that water evaporated. So we've got to get the compost out there to get those microorganisms to pull those salts back into the structure of the organic matter and pull it into the bodies of the microorganisms so the salt layer disappears without you having to leach, without you having to do anything more to your property. The biology takes care of that problem. So here they are digging down into the soil, wanting to see how deep those root systems are going, and they're just being amazed at the number of nodules on the root systems of that clover. Big nodules that look marble size, not the wimpy little teardrop size. You've got to cut those nodules open, and they should be bright red inside, like a drop of blood. So you know good nitrogen fixation is happening. So looking down then, digging up that whole root system, you can see that this grower has that the above ground, the green part of the plant, he's holding it at his waist, and the roots are touching the ground. So that's in the first growing season that we are seeing these kinds of benefits. Let's take a look at a little bit of comparison. Which side in this picture is the plus biology side, and which is the neighbor's pasture that they re-sowed approximately 6 months earlier. You can see the ridges where they planted the seed, but that grass has not grown any more than that, and yet they're pouring on the toxic chemicals. They're putting out the inorganic fertilizers, which are salts, which will kill your biology. They're putting out toxic chemicals to deal with the insect pests. And yet right across that fence line, no toxic chemicals, no inorganic fertilizers. Which pasture do you want? I like the way you can't keep the biology on your side of the fence line. See, it's sneaking over. It's starting to move over to help the neighbor. If the neighbor would just recognize that it's getting some benefit, you just should charge your neighbor for fixing their soil like this. So this is in December. It's in the springtime period. The left side is the neighbor's farm. The right side is the plus biology. And so this is in the beginning of the third year that we've been working with these guys. Look at the paddocks a little bit later in the growing season. Can you tell which of the pastures that you're looking at here, can you tell which belongs to the chemical guy and which belongs to the biological guy? Look at the pastures that are brown, and you don't have any plant material growing. They're in the middle of a terrible drought that's lasted, I think, now about 40 years. When you've been in a drought for 40 years, is that really a drought? Or is that climate change? So, droughty conditions, you expect your pastures to turn brown in that late summer period, and that's exactly what's happening on the no biology side. But you can see the green pastures, still green even when everybody else's plants have stopped growing. Your grasses are still growing. The whitings went ahead and mowed a lot of the pastures and put away bales of hay because they had that much plant growth through that year. So, you know, just another picture. The whitings pasture has been grazed 7 times during that growing season, and the neighbor could not put their animals, they could not put the whole herd on that field because the grasses still hadn't grown. So these are some of the benefits of when we get that biology back into the system. Would anybody not love to have this pasture? So larger, deeper root systems, you don't have to water your plants through that summertime period. The cows aren't pulling the roots out. We reduced resowing costs, and when we're talking about reducing by $20,000 per pasture, per field, that's a serious amount of money. They don't have to put on nitrogen fertilizers, so they dropped a cost right there by $100,000 in the first growing season, and then every year that they maintained this program, they saved more money. They didn't put the inorganic fertilizers, they didn't have to deal with insect pests or diseases, they don't have to resow the pastures, everything's getting way healthier. They got rid of all of their manure pits, and they have now turned that area next to the barn that used to be manure pits, they've put that into pasture. They've increased their herd size by 15%. So more animals, but no more visits from the veterinarian. The animals are healthy, they're happy. We've increased the mycorrhizal fungi. In the first 3 years, we increased it from 4% on the root systems of these grasses to 87%. We are selecting for the highly productive grass species. And so the benefits to you, the benefits go on and on. When we first started working with these growers, these 3 growers, their bricks was down around 1 to 2 in the leaf material of their grasses. By the next year, we had increased that bricks 8 to 9, and then in the third year, the bricks got up to 11 to 13, and in places, we were getting bricks levels. Well, you all know what bricks is. We're taking the sap out of the plant, squeezing that sap out. You put it on a refractometer, and you measure the concentration of solids in that sap material. It's going to be mostly sugars from photosynthesis that you're measuring. You have to have all of the nutrients present in your plant for those sugars to be produced from carbon dioxide and sunlight. In some cases, we got the Brix reading up to 25 to 26. That's protein in the grass. And so all of the animals' health was improved. So in the first year, just going back, in the first year that we worked with just these 3 farmers, they started to talk to all of their neighbors. All of their neighbors were kind of hanging over the back fence going, what are you doing in there? How come you're not down at the feed store buying fertilizer? How come you're not getting the pesticides? What's going on here? And so they started explaining it to all of their neighbors, and by word of mouth, the next year, we tripled the number of people on the program. So in the first year, we had 3 growers. Second year, we had 5. The third year, we had 75. And then I came out and gave a talk and gave the data, showed the data from all of this work we were doing with these 75 growers, how fast we could turn around these guys who were going bankrupt. And we're now no longer going bankrupt. They paid all of their bills because of the increase in healthiness of that crop and the animals, the fat content in the milk. They're getting higher prices for their milk. So in the what was that, 4th year, the 75 growers got the information out to every dairy grower, every dairy person in southeastern Australia, between Adelaide and Melbourne, up to Wagga Wagga. All 275 dairy farms showed up at that meeting, and we signed them all up to start working on this project. So huge impact on dairy production, and of course in that moved to all kinds of other different farms. This is an example where in this organic system, and this is one of the things that's most amazing to me, that organic folks often feel like we've gone through the 3 years of conversion from chemical to organic farming, so of course all my bacteria and fungi, protozoa, and nematodes. My biology must be perfect in my soil. Really? Not the case. If you're tilling, if you're doing disturbances to the soil, you are not getting this biology back. So this is a picture of chard in their garden, and this is Daniel and Caitlin's property. And so what they did was put in organic chard all the way down this row. To the half of that row that's right closest to you, they applied a single compost tea. And this is a week later. Can you detect the difference? When you put biology into that organic soil, can you see the difference in production? Which end of this plant, of this row, do you want to have in your backyard, in your garden, in your fields? So that's how rapidly you can see these kinds of, benefits happening. Now, earlier this morning, I showed you the pictures of the onion fields. So I'm just going to go quickly through this. This is the chemical field. Look at the weeds. Look at the fact that those onions planted on the same day here as in the biological field. These onions are only about 2.5 to 3 inches tall. Look at that root system. Isn't that pitiful? Because of the compaction in that soil, there is no structure. And so when we're looking at the 2 weeks between the biology was put in, and here we are 2 weeks later, look at the size of that onion. We've had to back away to include all of that root system. That root system is going down about 1.5 feet as compared to about 3 to 4 inches when we're looking at the chemical field. No weeds. Look at the structure that's been built. You can see it with your eyeballs if you're getting the biology doing its thing and doing well. So, the soil food web. We've just got to get it back into the soil You have to, as you know, my panelists up here, my co-panelists have shown you examples from local areas. They're doing this. Most of you could probably come and chat with them and get some ideas of what works really well in this part of the world. So all the biology has to be present. You can't forget any part of it. It's kind of like, you know, you're only going to brush half your teeth, right? And then you're going to expect that you're going to not have to wear dentures. So don't forget any part of this system. It's the whole food web. We can return health to the soil. It's not going to cost billions. It's not going to cost millions. It's not going to take years. If we got everybody seeing you doing this organic agriculture and being highly successful, increasing yields, reducing costs, making it easier, we could take all of that elevated CO2 that's in the atmosphere and within 3 years put it back into the soil and reverse climate change. So that's the goal. It's not a big one. So thank you very much.